myself JV and Dr. Kiran Yadav. In this section I will discuss about acceleration. Acceleration is the rate of change of velocity. When the velocity of an object changes, the body is accelerating. A change in velocity can be either a change in how fast something is moving or a change in the direction it is moving. Acceleration occurs when an object changes its speed, its direction, or both. Let's see more about speeding up and speeding or slowing down. When you think of acceleration, you probably think of something speeding up. However, an object that is slowing down also is accelerating. Acceleration also has direction just as velocity has. So if the acceleration is in the same direction as the velocity, the speed increases and the acceleration is positive. If the speed decreases, the acceleration is in the opposite direction from the velocity and the acceleration is negative. A change in velocity can be either a change in how fast something is moving or a change in the direction of movement. Anytime a moving object changes direction, its velocity changes and it is accelerating. So the speed of horse in this carousel is constant, but the horses are accelerating because their direction is changing constantly. So you can see that in the diagram the horses are moving on a circular path. So at every point the direction of motion is changing. So if the speed with which the horse is moving is constant, still its motion is accelerating because direction is changing here. Now calculation of acceleration. To calculate the acceleration of an object, the change in velocity is divided by the length of time interval over which the change occurred. To calculate the change in velocity, subtract the initial velocity, the velocity at the beginning of the time interval, from the final velocity, the velocity at the end of the time interval. So then the change in velocity is final velocity minus initial velocity. We denote final velocity by Vf and initial velocity by Vi. So the change in velocity becomes Vf minus Vi. Calculating acceleration. Using this expression for the change in velocity, the acceleration can be calculated from the following equation. Acceleration is equals to change in velocity divided by time, which is equal to A is equals to Vf minus Vi divided by T. Here units are mentioned in the SI system. The unit of acceleration is in SI system is meter per second square, and the unit of velocity is meter per second, and that of time is second. If the direction of motion does not change and the object moves in a straight line, the change in velocity is the same as the change in speed. The change in velocity then is the final speed minus the initial speed. How is the acceleration for an object that is speeding up different from that of an object which is slowing down? Suppose a jet airliner starts at rest at the end of a runway and reaches a speed of 80 meters per second in 20 seconds. The airliner is traveling in a straight line down the runway, so its speed and velocity are the same. Because it started from rest, its initial speed was 0. If acceleration can be calculated as follows, we will put the value of Vf to be 80 meter per second and the value of Vi to be 0 meter per second and time 20 seconds. So the value of acceleration comes out to be 4 meter per second square. The airliner is speeding up, so the final speed is greater than the initial speed and the acceleration is positive. If the final speed was less than the initial speed, in that case acceleration will be negative. Now imagine the skateboarder is moving in a straight line at a constant speed of 3 meters per second and comes to a stop in 2 seconds. The final speed is 0 and the initial speed was 3 meters per second. In this case, if we calculate the acceleration, then the value of Vf is 0, Vi is 3, and the value of T is 2 seconds, not 20 seconds, right here 2 seconds. Then the value of A comes out to be minus 1.5 meter per second square. So this is negative acceleration. The stake border is slowing down, so the final speed is less than the initial speed, and the acceleration is negative. The acceleration always will be positive if an object is speeding up, and negative if the object is slowing down. So if there comes a term like instantaneous acceleration, then it is the acceleration at any particular instant of time. Okay, so instantaneous acceleration is basically the acceleration at a particular instant of time. So this was all about acceleration. Thank you.